Apache Spark is a framework for fast distributed in-memory data analysis, and Apache Cassandra is a distributed database management system that provides high availability and fast throughput. Today, we're collecting fast, big data streams from user behavior, smartphones, and sensors. And the disk checkpointing and query language that Hadoop MapReduce requires is no longer enough. Tim Berglund from Datastax came on to Software Engineering Daily to explain Apache Cassandra in a popular episode that aired a few weeks ago. On this episode, Tim returns to discuss how Spark and Cassandra can be used together to provide a stack with the analytics and storage that we need for today's distributed computing environment. Many fans of Software Engineering Daily might be listening through the browser, either on their phone or on the desktop. And the Practical Dev is the place to check out Software Engineering Daily from the browser. Practical Dev has teamed up with us to give a better browser experience, and you can check out our new site at dev.to/sedaily. That's dev.to/sedaily. After a quick word from today's sponsor, we will get to today's episode, Spark and Cassandra with Tim Berglund. Software engineers are always looking to automate their work. Software automation lets us get more done with the same number of resources. Investment automation works the same way. Wealthfront is an automated investment service that relies solely on software to acquire and manage client accounts. Traditional investment services have many humans in the loop, advising clients and taking fees. The problem with these older advisory services is that the advice that these services are applying is often so systematic that a computer could give the same answer, or an even better answer. Wealthfront takes a new approach with software-driven automated investment that provides better returns through software engineering. Go to wealthfront.com/sedaily to get a special offer for our listeners. $15,000 managed for free when you open your account. Don't pay commissions and account fees. Maximize your gains with Wealthfront's set it and forget it investment automation. Check out wealthfront.com/sedaily. It would support Software Engineering Daily, and it would also introduce you to the world of automated investment, so you can see if you like it or not. Wealthfront.com/sedaily. Thanks to Wealthfront for sponsoring the show. You've been a loyal sponsor, and we really appreciate it. Now let's get on with the show. Tim Berglund is the Global Director of Training at Datastax. Tim, welcome to Software Engineering Daily.
Hey, thanks for having me.
So we did an episode in the past about Cassandra, and we will put that in the show notes. But today we're talking more about Cassandra and Spark and the intersection between the two. And I want to start off the conversation at neither Spark nor Cassandra. So I want to talk about a hypothetical scenario. I am building an awesome new social media website, and I'm putting everything into MySQL, and my website starts taking off, and I want to scale the MySQL database. What are the problems that I'm going to run into?
Okay, well, the way I describe this is as if there is some hypothetical scale slider, right? Like, let's say you start off small and everything is great in your relational MySQL database, and you move that scale slider up as you're more and more successful, and various bad things happen to you as the slider goes up. And just not, to avoid burying the lead here, what ends up happening is that the database you have when you've maxed out the scale slider isn't a relational database anymore. It may be that there is a program called MySQLD that's running on servers in your cluster, but collectively the database is not relational. So let's just kind of walk through that. You start off and you design the schema like you learned in college as a nice, properly normalized database, and it does everything well, and it works, and it performs well, and then you get some scale, and typical kinds of things that you bump up against early on are things like, well, I forgot to add this index. This read is slow. Okay, you add the index and you move on. But then when things get really bad, you find that the joins that the database is doing, because it's a properly normalized schema, it will have to join. those perform poorly. They're too slow, and that's not going to work out. So you find that you have to start. And by the way, we're taking this from kind of a data model perspective and a physical topology perspective. So data model first. You find that you have to start denormalizing things. You have to make copies of data so you don't join as much. And well, that's a bummer. You don't like that. And then a little while after that, your writes start to become a problem, and you realize, well, I had added all those indexes because of these funky queries I wanted to do, and writes aren't performing well enough, so I have to start backing off on indexes and removing them so that I can handle my write workload. So from a data model perspective, those two things happen to you. So you've denormalized and you've given up on indexes, which means probably you've had to make changes to the way you write your data and denormalize even further. If there's fields you can't index, that's going to come back and touch your schema. So your schema looks less and less relational as you scale it.
So that's
the data model end.
Oh, okay. So continue.
Yeah. So then there's the physical topology. The kind of textbook way you're going to scale MySQL is you go from one server to a leader-follower sort of cluster where the leader is where you send all your writes, and you've got some number of followers that are replicating the leader, and you load balance reads to those servers. And that's fun. And that totally works. It gets you better availability. It lets you spread out your read workload among more servers. But that also then breaks consistency guarantees that you thought you had, and you probably built your application with the assumption that you had strong consistency, and you don't anymore. And it's kind of hard to make predictions about what the consistency behavior of the database will be at that point.
Okay, so at a high level, what are the penalties that we're taking in this sharded? If we end up with a sharded MySQL database, we do decide to scale with MySQL. Can we say anything about the availability or the consistency or what we have sacrificed as we've sharded this MySQL database?
Right. And actually, let me dig into sharding just real quickly there, because we hadn't even gotten to that point. After we made those data model compromises and we started load balancing our reads with a leader follower kind of thing, at some point that leader database is still going to run out of gas on writes. Okay, if you can turn the scale slider up to where that one machine can't do it anymore, and then basically you need to break your database into a bunch of little databases. So you have lots and lots of those leader follower clusters, and you break up your data set based on some field, and assign, say names A through B to the first server and C through F to the second one, or something like that. So that would be sharding. And the question, what do you give up? You definitely give up consistency once you start doing read replication. You don't have a strong, consistent database anymore. If you are reading from a follower and writing to the leader, you aren't guaranteed that you will be able to read your writes. So that's a bummer. That's not the end of the world. Sometimes it's totally fine to do that, but that architecture doesn't give you a lot of control over that. You're just saying, well, you're done. You don't have strong consistency, and deal with it. Clearly, I'm setting up for a bunch of very partisan Cassandra solutions.
Certainly. Okay, so teeing you up further. So in order to scale our databases, we're going to just give up consistency. We're going to build in some sharding and rebalancing from the beginning and use Cassandra. Right. Those are the things that we get out of Cassandra. And we did a whole show about this, so you don't need to go into that in severity. But
strongly recommend you go back in the archives and listen to the show.
Definitely. But coming back to the popular social media site that we now have, so I can hire a data science team and a data engineering team, and I want to start doing some analysis on the activity that's going on across my site, which I now have managed with Cassandra. And so, let's talk about data analysis technologies like Hadoop, for example. So if I'm using Cassandra as part of my Hadoop cluster, am I using it in place of HDFS, or am I using it side by side with HDFS?
Yeah. So If you were doing that with Hadoop, and by the way, I like this question because you're assuming you did the database right to begin with, but a trade-off that you made there in using Cassandra is that it's for the most part explicitly bad at analytics. It doesn't really have those features built in. It's just not built that way. So you say, okay, we'll use Hadoop on top of that. Now, to my knowledge, there's not an open source solution to this, but I work for Datastax, and our commercial product provides a Hadoop integration, which does exactly what you said. Basically, HDFS is implemented by the Cassandra cluster. We've got a layer in there that implements the HDFS APIs, except all the data is stored in Cassandra tables instead of actual HDFS tables. So you can run Hadoop stuff. You pick your favorite Hadoop animal or API or thing from the ecosystem. Or if you hate life, you can just implement MapReduce interfaces and write that code directly. But that will analyze the data directly in the Cassandra cluster in that case.
So in that scenario, how does HDFS compare to Cassandra?
Yeah, okay. HDFS in that scenario, or just HDFS generally, is a distributed file system, and it's built to be a distributed file system. So it's real good at storing relatively big chunks of stuff that don't change as often. And Cassandra is optimized as a transactional database. That's from first to last. Its purpose in life is to be a transactional database. What that means is it's optimized to read and write relatively smaller pieces of data that are assumed to change often and get that work done with very low latencies, like single-digit millisecond latency. Whereas HDFS, you're thinking, I've got a bunch of data that I have to dump in a file system and keep it there. This is really an important architectural distinction to make, because it's not like one is bad and the other is good. They're two different kinds of data storage, and you need to either use a file system or use a transactional database, depending on what you're trying to get done.
Okay, well let's talk more about the strategy for what tool we are actually using for the data analysis, because Hadoop is a nice place to start the conversation, but whether we're using a MySQL storage or Cassandra or HDFS, the storage layer doesn't really matter if we're not even doing the data analysis right. So I want to move towards a conversation of Spark, and I want to get there by first talking about the fundamental changes to our world that have happened since Hadoop was popularized. So what are the things that changed in the world that kind of made Hadoop a little dusty and not well suited to the types of data analysis that we want to do?
So I think if I could kind of take that in two parts, you had a guest on recently. I guess that's relative to, we're recording this in late April 2016. You had a guest on recently who was one of the original creators of Hadoop, and he distinguished between HDFS and MapReduce. And he said something that I really loved, and I've quoted him several times since. HDFS is a cockroach. It's going to be around for a long time, and couldn't agree more. It's not gotten old. It's like absolutely the right way to make a distributed file system, and should win over Cassandra in certain kinds of cases. MapReduce, I think, I almost don't think it's that something has changed in our world so much as this was the thing that we built 10, 12 years ago. And, building new things is really hard, and it was amazing, and it worked, and it solved a problem. And it was, in a sense, as a community, the best that we could do at the time. And now we're seeing there are probably better interfaces that we can expose to developers for getting the same kinds of work done, more just like a second generation. So I don't even see it as the world has passed Hadoop by. It's that MapReduce, that's kind of tough. We could do that a little better, and that's kind of where I see Spark fitting in.
Well, one thing that has changed is the volume of data and the velocity of that data, because we have smartphones, more sensors and stuff. And so there's just more data. There's more updates that kind of need to be processed with lower SLAs. And by its nature, Hadoop does things in batch, and maybe that kind of makes it a little outdated.
Yeah, no, okay, I see where I guess as a big data guy, I should have had that. That would have been a great canned answer for me to give. You're so right.
Yeah, you need to work some more CIO vendor booths at some more conferences.
Oh, this is terrible. No, volume and velocity and all that. That was the original Hadoop sales pitch, of course, but it has gotten worse, or in my case, better. That problem has only accelerated and become more urgent. And you're making an interesting distinction here. Hadoop is, and Spark is too, but Hadoop is very much a batch mode technology. And in its default use case, Spark is also a batch mode analytics technology. But you're seeing the combination of systems like Cassandra and Spark these days answering kind of what we call operationalized analytics problems, where there's real-time I'll probably say that several times. Real-time transactional data happening in a transactional database, and analysis happening on top of that without the usual next day ETL sort of time constant in the loop.
Yeah, so I want to talk about some of the downsides of MapReduce, because obviously, even in Spark, we are still doing map and reduce, but it's kind of the way that Hadoop looks at MapReduce that's problematic. And I think this is really epitomized by the fact that Hadoop has to write everything to disk, even the intermediate steps. So explain why that is, and why is that a problem?
Okay, so Hadoop has an opinion about where your data lives. And like we said before, Hadoop is both a set of, it's really three things. It's a set of distributed programming APIs, it's job management to deal with the code you write with those APIs, and it's this file system. So, broadly speaking, file system plus distributed computing framework. And the file system works great, but the distributed computing framework, it holds the opinion that, well, of course, your data is going to be in HDFS, right? I've already got this big distributed file system on disk, and if there's any caching, that's just going to be operating system page caching. Like, I don't know anything about caching. We're just going to write stuff back and forth these files, and that's how it works forever. So from a Hadoop architectural standpoint, disk is where everything is. Now, one of the things that Spark does, and I think Spark wins in a few ways, but number one, it does not have an opinion about where your data should be stored. Lots and lots of Spark jobs that are running in the world today are running on top of HDFS data, and that's totally legitimate. Fortunately, lots of Spark jobs are running on top of Cassandra, from my perspective, so that's totally legitimate. It could be files in S3, right? It can be whatever. Spark doesn't care where the data lives. What Spark does do is it does give you opportunities explicitly to cache various kinds of intermediate results and say, hey, this point in my computation, I want to persist this in RAM. And that never needs to get written to disk ever. And that's fine, because Spark is kind of standing aloof from the whole storage problem, saying, as long as it's somewhere, I don't really care where. It kind of gets to invest its architectural energy in figuring out, hey, should I even be writing stuff to disk, or should I try to keep things in memory? And a lot of optimizing a Spark job has to do with, a Spark application, has to do with figuring out what parts of the computation to keep cached in memory.
Well, let's talk more about that. With what kind of frequency does a Spark job need to write to disk, and what are the alternatives? Like, what kinds of caching layers am I using?
Yeah. So there is one thing this is why it bugs me a little bit when people refer to Spark as an in-memory framework. It's not. It's a framework that loves memory and considers memory a first-class place for intermediate computational results to live. Encourages you to think about what gets cached and make decisions about what gets cached. It is not an in-memory framework. So there's a thing that happens within a Spark application called shuffling, and that's a thing that you need to be aware of when you're optimizing an application and you kind of draw it out. You need to look for where do shuffles occur and am I reshuffling when I don't have to? And we won't go into the details, but shuffling is this thing that happens to a data set. And shuffling uses the disk. So it's not that Spark is inherently in memory. It uses disk sometimes. But other than that, when you're just, you're starting with, and we could even talk about the computational model and the data model a little bit, but you read some data in, you do some stuff to it, you do some more stuff to it, you run an aggregation, all this kind of thing. If you don't shuffle, you never have to touch the disk. It's possible to do it all in memory. And of course, you want to do as much of it, to persist as much of it in memory as you can.
So as a programmer, there are some scenarios where I want to write to disk. Obviously, this is write more aggressively. I think this is called checkpointing. Is that right?
Checkpointing is a thing in Spark streaming.
Okay.
Yeah. So that does happen, but and we've sort of implicitly been talking about the batch mode conventional Spark.
Sure.
Checkpointing is a streaming thing where, and again, we can kind of break down the architecture a little bit here, but just imagine you've got some streaming data source. There's a thread running on one of your nodes in your Spark cluster reading from the Twitter firehose or whatever. And somebody else, there's this job running over the cluster that's doing some kind of computations over that thing. You will want to checkpoint those results at some point so that if you had to restore a failed node, you don't have to recompute the entire universe.
Okay. So let's talk more about like Spark's, just I guess the basics. I mean, the key abstraction of Spark is an RDD, the resilient distributed data set, and we've done a bunch of shows about Spark, so it's another thing I won't go into too much detail, but there are two types of operations that we can perform on an RDD, which are transformations and actions.
Yes.
Can you explain what each of these does to an RDD?
Absolutely. It's kind of funny. When I talk kind of my stock Spark and Cassandra conference talk, I normally get between 45 and 90 minutes to give an introduction, so you can't go into too much detail. And I always start by saying, well, MapReduce is terrible, right? We'd never want to do MapReduce. We'd rather transform an action. So you need to point out that map and reduce are there in the Spark architecture, winking at you. They're very much present in this situation. And transform and action are to a first order approximation. They're like map and reduce. So an RDD is this distributed bucket of records. That's all you need to know about it. It's a it could be a text file where each record is a line or something like that, but it's this distributed bucket of typed records. And if you want to change them, then you run a transformation on the RDD. For example, I live code this thing where I join a Cassandra table to a CSV file, which sounds like something which ought not to be done, but I read in the CSV file, and at first that first RDD is got strings in it, just lines in the text file. Well, we all know that it's a CSV file, which means we can split it on a comma and parse the one of them into a float and one of them into a UUID, and that would be a transformation. So we'd take that text file and actually write code to split the CSV file and convert types and return a tuple that's got things in it. And so that second RDD is a purely functional transformation of the first one. Then I could say average the numbers. It's the demo I like to show is real-time movie ratings over some database of movies. They're made-up ratings, but it's a good story.
Canonical.
Yeah, absolutely. And so we would run an action on that RDD that averages the ratings, and that'll perform some actual computation.
Right. Okay. So let's say, I want to talk more about kind of just, I guess, selling this to people, like this idea that, okay, Hadoop is maybe not your best option these days. Spark is, kind of more compelling. So like if I'm running some giant company with a lot of data, like if I'm an insurance company or like a food processing conglomerate, let's say 2 or 3 years ago, I finally got my Hadoop cluster online. So are you telling me that I need to migrate to Spark now if I want to be, getting the most out of my data?
I don't know that I would say that, but I like the question about selling it, trying to show people what the advantages of this thing are. So let me say why I would say no to your question, but kind of give you my sales pitch for why I think this is interesting. And that'll be relative to Cassandra, obviously, because that's kind of where I live.
Which we'll get back to in a sec.
Okay, good. But I would not rip out, if you have a Hadoop-based solution and it works, I would not throw it away and replace it with Spark. That's a good way to get fired. However, I would not use Hadoop for a new design, and I would have a couple of reasons for that. Number one, and it sort of depends who I'm talking to. If I'm talking at the exec level, I'd say, well, better performance, lower latencies on queries, more efficient with compute resources, cloud bill will be lower. The website says it's 100 times faster when it's in memory. That's a benchmark. We all know about benchmarks, but it is faster. Okay, whether you're going to clock 100x or even 10x, there's a consensus that Spark runs faster, which means you're going to spend less on your compute resources, which are probably going to be in the cloud. So that's the I want to say bean counter argument, but that's not to denigrate bean counters. That's really important. We want to save money. If I'm talking to developers, I'm going to say, look, go ahead and implement the map and reduce interfaces if death is the thing you want. Nobody codes against that. Everybody is picking some higher level API in the Hadoop ecosystem, right? And that's why that's such a ridiculously complex ecosystem, is because that interface is painful to program. So all this other stuff has cropped up. And look, there are plenty of ways to succeed. I realize I'm being a little straw man-y with that. There are going concerns that still make productive use of that ecosystem. But for new designs, if I'm talking developers, I'd say, man, look at this code for this Spark application. It just looks like code. And when you're doing it, it feels like you're programming. It doesn't feel like you're getting hit on the head, or like all you have is SQL. You've got a language available to you and an API. And so it's much more developer friendly, in my opinion.
Well, I kind of like that model of I think there are a lot of people out there who are in really big companies, but they want to figure out how to get the newest, freshest technology going in their company. And I kind of like that model of whether it's like a skunkworks project or just like a one-off thing that needs to be built, and you can do it in new technologies, like just do it in Spark, and then you can be that guy in the corner who implemented the thing that works a lot faster than everything else. And then maybe everybody else will get envious and start using Spark instead of Hadoop.
Right. Nothing like success to help make the argument if you can prototype something, and that always works.
Right. Okay, so let's work our way back to the discussion of storage. So I want to gradually get to the conversation of Spark integrating with Cassandra, but let's talk more abstractly. So talking about how Spark generally connects to a storage layer. Let's go back to the replicated MySQL cluster. Let's say I never migrated anything to Cassandra. I've still got a replicated MySQL cluster. Would that integrate with Spark?
To my knowledge, no. There could be something that's out there that I don't know about, but there would need to be a MySQL connector that gave the Spark context interface the functionality that it needs, and on a Spark worker node does the actual communicating with the MySQL database. There's a lot of work to do there to get the two things talking. And I don't think that's been done. That could be total ignorance on my part, so I'm sure a listener will point it out if there is such a thing. But if you wanted to Spark analyze your MySQL data, then you are in the basic topology of the classical data warehouse, right? Where you're going to ETL out of your MySQL, dump into something, probably files, and Spark over that. And nobody likes the ETL delay. You can get super high performance on top of Parquet files or whatever you put it into. So you could get, some pretty sick numbers you clock on the Spark jobs, but from a block diagram perspective, I wouldn't be super happy with that system.
So basically, the lesson here is that there is not an API for Spark to interact with the abstraction of a SQL database. I mean,
I don't think so.
Yeah, unless one gets written at some point.
And it's not theoretically impossible, but it seems like a bad idea.
Well, so contrasting that with Cassandra, so how do we combine Cassandra and Spark? Because if it doesn't work with Spark and a replicated MySQL cluster, give me an idea of what Cassandra has in terms of its communication layer or its abstraction layer that what Cassandra has that MySQL does not.
Got it. What it has is the Datastax Spark Cassandra connector, which is available as an open source project. It's on GitHub. You can just Google Datastax Spark Cassandra connector, and you'll probably get to the repo as your first hit. And so that's available, and that's basically becomes a dependency in your build. So you're writing the developer experience there is I'm saying, all right, I'm writing a Spark application, and I'm going to run this on my Spark cluster, and my Spark cluster happens to be coextensive with a Cassandra cluster. So every Cassandra node is also going to be a Spark worker node, probably. Just keep it simple. And then I'm writing this application over here on the client, and the Spark Cassandra connector is a dependency of that. In effect, it enhances the Spark context interface to have some methods for reading and writing Cassandra tables and doing a bunch of other cool stuff. And of course, that code gets shipped off to the Spark nodes when the job runs so that it can do the communicating with Cassandra local to the node.
Okay, so can you give me a little more of an idea of what was involved in writing that Spark connector?
Yeah. I'm not on that team, so not directly, but a lot. It's a pretty significant piece of code that is a part of our commercial product. The integration between Spark and Cassandra and Datastax Enterprise is a key part of the value prop, the analytics value prop of the stuff we sell. But we actually open source this component just as a way of, and by the way, of course, the obligatory hashtag safe harbor. I'm sort of talking about public things and not anything I say. I'm mostly speaking as Tim Berglund, and facts externally observable about Datastax. And because they're such great guys at Datastax, they open source the connector as well.
Right. No, I mean, we've been doing a lot of shows recently kind of about this this build versus buy debate, and I don't know if people actually care about it that much, but I find it very interesting. Like this idea of when do you choose the managed solution versus when do you write your own or when do you implement your own? Obviously, by publishing the code for the Spark driver, Datastax is basically saying, all right, pick your poison. If you want to roll your own Cassandra and Spark, go for it. Otherwise, you're welcome to go with Datastax. And I think it's just interesting because there's different companies that are in different phases. And if you're in a phase where you want to buy or you have the liquidity to just buy a solution, it's kind of like, why not? Focus on your core business. But if you're in a situation where you maybe don't have a budget or whatever, then whatever, build it out, be an engineer. But it's there's certainly merits to both sides. I think there is maybe an unnecessary suspicion of managed solutions
among engineers. Yeah. And I totally understand that suspicion. And just, I think as a person, whose heart is oriented around building things, which is what engineers are, I don't write code for a living anymore, but I really get that. I mean, I don't want to use somebody else's dumb stuff. I want to build it myself. It'll be better. And that's a completely built-in assumption in my mind. I don't think that is a faithful assumption, though, in helping us build the best thing we can and make the best use of capital and turn it into the most awesome software that we can, because you kind of have to decide what business you're in, right? And it might be that your engineering excellence as a company is a a strategic advantage for you and a strategic differentiator for you. Most companies, that's not the case. Most companies, their engineering excellence is, kind of within a standard deviation of the average. That's by definition. We all think we're better than average, but most of us aren't. Most of us are just kind of ordinary engineers. And so it's hard enough to build the system that the business needs you to build to deliver the value that you're trying to deliver to customers. So you probably should think about the stuff that you can buy. And by the way, I've been following the build versus buy discussions, and a thought I'd even add to that is sometimes adopting an open source tool is buying.
Yeah.
Even if you're not spending money, you're not writing it yourself, and the investment you have to make, if it's a complex thing, in using it is akin to buying, even though it's not a budget line item. So it's kind of an in-between, a weird in-between thing using open source.
Okay, well, getting back to Software Engineering Daily rather than CIO discussion budgeting daily.
It's your next podcast.
Yeah, that's the spinoff. If anybody wants to come on as a host for CIO Daily, let me know. But you talked about kind of how this looks topologically. If I've got Spark with Cassandra, I want to have my nodes that are Cassandra nodes also having some kind of Spark. They're also Spark nodes. So what does that node look like?
Yeah. The simplest case is you have a single data center Cassandra cluster, 5, 10 nodes, 20 nodes, whatever, 100 nodes, doesn't matter how big it is. And every node is obviously running a Cassandra process. Every node is also running, is being a Spark worker. And one of them is a Spark master. Or if you've got high availability setup and leader election and everything, you could have highly available Spark masters, but one of those nodes is the Spark master. All the rest of them are workers. And so as the jobs and tasks in a Spark application get distributed by the master to all the workers, the parts of the Spark application that are dealing with Cassandra data, they get to deal with it node local. So the Spark Cassandra connector talks directly to Cassandra and does that, local work there on the node as it's able. So, and this gets into, and everybody should refer to the previous Spark episodes so they can get the architecture solidly in their head. But an RDD is, the assumption is it's too big a bucket to keep on one computer, so it's distributed over lots of computers. That's why you've got a thing like Spark in your world. And that partitioning of an RDD, you want to align that with the way the data is partitioned in Cassandra. And when you way to put this, when you're doing computations that mix a Cassandra table RDD and some other data source, one of your optimizations is to make sure that other data source, if it has a common key with the Cassandra data, will be partitioned in the same way. So, in other words, you try to be smart and get stuff to be node local anytime you can. And, the Spark and the Spark Cassandra connector are handling that for the Cassandra data. Sometimes you have to think about it for other kinds of data sources.
Okay, and this question could take up probably an entire show, but let's say if I want to actually run a Spark job, whether it's like a MapReduce or whatever, like some simple aggregation, what does it actually look like? So how does it get executed across the cluster if I want to execute this job?
Yeah, okay. So from a code level, it looks like we could say we're doing it in Scala or Java. Scala seems to be one of the two major native languages of Spark, Python being the other one, but the Java works just fine. So say it's Scala or Java. It looks like you import some interfaces and some classes, and you create an instance of a thing called Spark context. You pass it a configuration object that gives it the address of your master, and then you have this Spark context object. Its API is your distributed computing API. You use it to create RDDs. You'll get RDDs, and you'll transform them and create new RDDs, and you'll run actions on them and create still more RDDs, and eventually you'll collect some kind of result back to your application. So from a code perspective, it looks like you are writing a program, and it is a beautiful thing.
And so if I want to write that data back into the cluster,
yes,
into the Cassandra cluster, what does that look like?
That looks like a method called save to Cassandra. So you've got a method called Cassandra table that'll query from Cassandra, and then you can save it back, which is exactly what you're going to do in the real world, right? You're going to read in some stuff from Cassandra, maybe some other non-Cassandra data if you're super cool. You'll do your analytics, and then you'll write that back into some other table, which the application can then read with famous low latency and show those results like that.
So what are the common failure scenarios that can occur when I run this type of job?
Oh, good question. And kind of an operationally related question. So I always like to bracket my operational answers with I've never been Mr. Ops, and so I'll give you a simple account, and it's always interesting to dig into the real war stories of the people who have been running giant clusters. But things break. Obviously, nodes fail. And that's an assumption that any distributed computing framework makes. And so you have to do things like part of your RDD goes away and has to be recomputed. And so that'll affect latency of an application, right? Something that normally runs in 15 seconds. If a node fails, you have to figure out that the node fails. You have to reconstitute that parts of the RDD, the parts of the RDD that were on that node, and so on and so forth.
Right. Okay. So a few ways for using Spark are Spark SQL and Spark Streaming, and we talked about Spark Streaming a little bit earlier. But let's talk at a more high level. Like, what are the use cases where I would want to use each of these? Okay.
Spark Streaming is easy. That really implies that you do have some kind of streaming data, and from a Cassandra perspective, or even the kinds of stuff I hear about at Datastax happening, streaming data is not unusual. We like IoT use cases. Cassandra is pretty friendly with time series data, and time series data is fundamentally streaming data. So that would not be particularly unusual. The default thing to do in Cassandra with streaming data is to write it into a time series data model. Basically, you're just storing it in a big giant database. That's an option, and maybe you want to do that, but you could also Spark stream that stream and do some computations in flight on that. And that I just, without saying Lambda, I just kind of described a Spark plus Cassandra Lambda architecture there, which you could do. You do your streaming in Spark, and you also write to Cassandra, and then you could have a traditional batch Spark job, do analysis over that, whole record of all of the Spark data. So streaming, if you've got, high-speed data coming in, that sort of naturally recommends itself. And Spark SQL, so this is, I'm really interested to see how this works out. Like over the next year of people building systems, when does it feel right to do one versus another? We've been talking about RDDs as the basic abstraction for data, and an RDD is a collection of typed records. With Spark SQL, I always have to be careful, and there's data sets, which are a future API or an experimental API in Spark 1.6, and then data frames. And stop me if I'm getting those reversed, because I always do that. But data frames are the things that you get in a Spark SQL query. So basically what Spark SQL is a way of, instead of your data just being typed records, it's records that have named typed columns in them. So it's like an RDD that resembles a distributed database table. Mm-hmm. That's what a data frame is. So you can certainly get the Spark Cassandra integration, the connector will let you run Spark SQL queries on data frames that you get from Cassandra tables. So if you want your API, your programming model, to be the structured query language, if that makes sense to you, then that's a good API. So why would you do that? Well, you're comfortable with it. You want to expose it to business analysts who can't write Scala code but can write SQL. Maybe you have some analytics tool that you can manage. You can imagine integrating because it'll spit out SQL and you can get the SQL results. And, it's pretty standard technology. So I see Spark SQL as being incredibly approachable, super easy to use, and it feels like there's some integration points there where it's going to stick out. On the other hand, why would you use the conventional RDD API or the future dataset API? That feels more like writing a program. As a developer, you have this API, and allegedly these things are distributed, but you wouldn't know. That's all abstracted away. And and if you have things to do that would be unnatural in SQL, but would be quite natural in Scala or Python, then you still have that API available to you. That's always been true of Hadoop, right? Getting back to Hadoop, but nobody has ever wanted to go there. Theoretically, you could always shell out to map and reduce, but that's painful. In Spark, you've got the higher level things, but diving down to the bare metal of Spark doesn't feel all that much like metal. It kind of feels like comfy chair.
Okay, so I want to talk about some other tools that are in this space and how they relate to the idea of Cassandra and Spark together. So, for example, HBase. I haven't done any shows on HBase. I don't know much about it. How does HBase compare to Cassandra in its interaction with Spark?
All right. The first question, how does HBase compare to Cassandra? I think they've been growing apart a fair amount in terms of data model. Cassandra looks a whole lot more tabular these days, and more trying to look as relational as it possibly can. And Cassandra, HBase has been an attempt to build a tabular or big table database on top of HDFS. And it's got successful deployments, and it works, and there's no doubting that. In terms of a stand-up fight between the two, if you're going to do a bake-off, usually Cassandra's going to win that if latency is important, because it doesn't have a commitment to being built on top of HDFS. It can make its own decisions about storage, and those are all optimized around latency. HBase is a semi-tabular database built on top of a file system. Cassandra is a tabular database, period. And you can run Spark on top of HBase data. That's just fine, just like you could with Cassandra.
So maybe you answered this in the last episode or previously in this episode. So what are those other types of things that Cassandra is storing to? You said HBase is highly coupled with HDFS. What kinds of things would Cassandra be storing or caching to? So Cassandra manages its own storage entirely, and that's a subsystem that is subject to ongoing refinement and evolution. And the recent release of Cassandra 3 made some pretty important changes in the way that works. So basically, it's just being its own storage engine, and I think we talked about that in the last episode. But if not, the basic story there is that Cassandra is a log-structured merge tree. Its storage engine is that, which means it goes through a lot of trouble to make sure that when it writes to disk, it does these sequential, immutable dumps of new file content on disk. So it's a fairly high bandwidth, blump, 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 every once in a while, dumping new content. And that creates its own problems, right? Then reads can become a problem, and you have to compact them, and it solves all those problems. But it can solve all those problems itself, rather than worrying about what the lower level of abstraction. Exactly, because that is what it is. It is a program that presents an API and stores data on disk. So it has to be good at that. So, do I want a stack like a quote big data stack? Do I want something do I want Cassandra and HBase? Do I want HBase as my way of dealing with HDFS and Cassandra alongside that for some reason, or is that just would I never have that?
Yeah, I never say never, but that doesn't strike me as a new designs kind of approach. You have to. Let me talk about HDFS versus Cassandra and give some architectural guidelines for how to think about that decision. I think it always comes down to you mentioned velocity. How fast does your data change? So if you have a transactional database where reads and writes in the database are reflecting business activity. Now, business activity can literally be people clicking and initiating commerce. They can be sensors doing things if the business is a giant global plant of IoT stuff, whatever. But if the reads and writes are, as it were, synchronous to business activity in the world, then they're going to happen a lot and latency is going to matter a lot. The quality of the system, the value of the system will be a strong function of the latency of those reads and writes. That means you want Cassandra. Okay, that is a strong indication that Cassandra is the thing for you. But to get that done, Cassandra has to kind of spend money. It's got to very directly use RAM to babysit stuff on disk. And once you dig into the architecture enough, you can see this. We got some great stuff here. Shameless plug. Academy.datastax.com. There's a class called DS201 that digs into some of this in the storage engine. It's taught by my friend Patrick McFadden, who's well known in the Cassandra community. Great course. Anyway, it'll give you the details. I'm just saying you have to spend RAM to be good at those low latency transactional reads and writes on disk.
Yeah.
Well, what if you don't need to do that? What if the low latency stuff doesn't matter and you're just doing a data lake, right? And you're just dumping data into this thing and you'll figure out how to query it later. Mm-hmm. Well, then you would rather be able to have, 40 terabytes on a node instead of 3, a bunch of disks, and you're not as worried about speed. So if the transactional characteristic isn't present in the system, then the economics don't work out in Cassandra's favor. You're wasting money, and HDFS or something like realistically, HDFS is the thing you want.
Okay, that's really useful. I really appreciate that. So there's also these tools like Impala and Drill, like Cloudera Impala and Apache Drill, that let me read from HDFS quickly. If I use Drill or Impala, is that gonna would that maybe fit somewhere on the spectrum of how I don't know how quickly I need to access my data, or further down the spectrum from the data lake?
Yeah, I don't want to say too much about those because I don't know them well.
Okay.
I don't. I mean, I know they're not outside of very focused parts of the Hadoop community. They're not. I don't see super wide uptake for them. Mm-hmm. But from an architectural standpoint, I don't know them well, so I'd probably say the wrong thing.
Sure. Okay. Well, what about like talking about different technologies at the streaming layer? Are there some conditions when we would want to use Storm with Cassandra rather than Spark with Cassandra?
Yes. Lots of people do that. That's the 2015, I think 2016 canonical Lambda architecture has got Storm in there. But if you've got Hadoop, or pardon me, if you've got Spark in your life and Cassandra there, then it is a valid question whether Storm is the right thing to do. Again, from a greenfield standpoint, if you're building a new system, you might, in fact, you're probably going to be able to have fewer moving pieces if you just use Spark and Spark streaming and forget about Storm. There could be considerations, and the devil's in the details, that could push you one way or the other, but I would definitely try to solve the problem with Spark streaming if I were going to use Spark for my batch mode computations as well.
Okay. Have you looked at Apache Flink at all?
No, not in detail anyway. I'm aware of it, but it's just not a thing I've been able to dig into too much yet.
Sure. So why do you think Spark took off to the degree that it did? Was it the technology, or was it the intersection of technology and the community, or was it the charisma of the leadership, or what was it exactly?
I think this is probably a non-expert opinion here, so I'm just kind of saying what I think. But I think developer friendliness is a lot of it. I mean, we talk about performance gains, and I know it's faster, and I know the use of RAM matters a lot. I don't think Spark is as in actual use is as much faster as the numbers we typically bandy about. we say 10 to 100 times, and I think 2 to 3x might work out to be closer to the truth. 2 to 3x is important, but that's not stop everything, I'm going to learn a new thing important. I think developer friendliness is a bigger factor than we sometimes give it credit for. Using the thing feels like programming, and it feels very, very natural. And that's funny because as a Cassandra advocate and guy who works for the Cassandra company, as much as there is a single Cassandra company, developer friendliness has never been Cassandra's strong point, right? But I think Spark is winning, at least in part because of that.
Yeah, well, I guess that lack of developer friendliness has kind of been the Datastax arbitrage.
Yeah, good point, right? That's even with the Spark Cassandra integration. We open source the connector. You could totally do that. You can do anything you want. But, not everybody wants to be in the business of figuring out how all these open source components work together. Sometimes you want to install software, and instead of spinning up all these things, you type, DSE Cassandra -K, and Spark's running now. So that's that integration is definitely valuable.
So since this show has been basically about Spark and Cassandra working together, are there any other interesting technologies that you're kind of seeing on the horizon right now, or maybe, I don't know, older technologies like Kafka that are developing new features that are really exciting to you right now, as you're looking at different things that integrate with Cassandra and perhaps with Cassandra and Spark?
Certainly the Spark Cassandra integration and the mixing of those two, that's been much on my mind recently. And Kafka seems to be going from strength to strength. I hear about it being used a lot in Cassandra deployments. It really seems to go along there well. And it seems like people are trying to settle into those two things and seeing what they can build. And I know there's lots of other stuff going on, but there isn't any of the other things that has really popped up on my radar as strongly as those have.
Well, I guess there's plenty of depth at that point of integration. Okay, well, Tim, thanks for coming on the show once again. This has been a pleasure, as usual. So, thanks for coming on Software Engineering Daily.
My pleasure. And one more shameless plug. If you want to hear more about Cassandra and Spark, you can go to Datastax Academy, academy.datastax.com. There's a course on there that's got like 5 hours of me talking about Cassandra and Spark, which is way too much Tim. So break it up into small sessions.
Okay, well, that's great. I'll put that in the show notes.